Welcome back. Let's look at solving some of the Chapter 8 problems out of our Collier and Evans textbook. The first type of problem we're going to solve is one in which we're calculating cycle time. And you can see the formula given here, A divided by R. A is what's the available time to produce an output, and R is what is the demand forecast. So we'll use the solve problem from page 155 in the book. An assembly line has 6 workstations, and we'd like to produce an output of 300 reels per day. Now what's important about using this formula is that we have the same units of measurement on both our A and also the R. Okay, so now if A is the available time and we have a 7.5 hour work day, we want 300 reels a day, and the sum of our task time is 8 minutes per reel. Then we might want to express the available time in terms of minutes per day. Okay, so if you have 7.5 hours in a work day, or 60 minutes per hour, okay, then that would give us 450 minutes per day, and the output R is already expressed in reels per day. So if we had 450 minutes per day divided by 300 reels per day, then that would give us a cycle time of 1.5 minutes per reel. And so that's very important that we keep track of our units of measurement and that they cancel and they give us, and we can recognize what the answer units of measurement are in. The second part of this was the assembly line efficiency, and so the sum of the time, we're told the task times is 8 minutes, so that'd be 8, and we're dividing that by N, which is the number of workstations, and remember there's 6 workstations. Our cycle time we just computed is 1.5. So 8 divided by 6 times 1.5 would give us an 88.9% efficiency. Total idle time, so N number of workstations, cycle time, and the sum of the task times. So again we have 6 and 1.5 minus 8. That would give us 1 minute per reel of idle time. Okay, let's go to the next page. That just shows the answers to what we just solved. Now let's go to the next problem that we're going to solve, looking at arranging workstations and assembly line balancing. We'll be using these different formulas that you can find from the book. So here's the problem that we're solving from the book, and you can see the precedence network diagram shown here on the screen, and within the problem description we're told that the cycle time is 6 minutes per unit. So that was computed in a way similar to what we did in just our last problem. Now in deciding how to allocate these tasks to workstations, then we start by looking at those that either don't have a precedence or the precedence has been satisfied, and then starting with the longest time. So here at 5 it has 3.5 minutes. It doesn't have a precedence for that. It's the largest time of those available, which would include these up here. Okay, so the first task that we would assign to workstation A would be task 5, and that's going to have 3.5 minutes. Now we'll continue to add tasks until adding the next task would exceed our cycle time. So the next one to choose from would be the 1 and the 2, This one has 2 minutes, so we would add that next. And so that would give us a 5.5, so we're still less than 6. The next one we could add, so let me write that one down here. So that was 1. It looks like we could also add task number 2, which has 2/10 of a minute, would be giving us a total of 5.7. If we look at adding either 3 or we can add 6 because 6 hasn't had 4 satisfied. So if we added 3, that'd be 1.5 minutes. We'd exceed the cycle time. And so our total time for workstation A would be 5.7 minutes. And then we could start by adding 3 down here. That would give us 1.5. If we then added 4, so adding a half, that would get us to 2. We can then add 6 because 6 has had both 4 and 5 satisfied, so those precedents are there. So that's another 1, so that's going to take us to 3. And then adding 7 and 8 would be another 7/10. So 3, 4, 6, 7, and 8 would give us a total of 3.7 minutes. Because our cycle time is 6, our idle time here would be 6 minus 5.7, so 0.3. Idle time here would be 2.3, giving us a total time of 9.4, total idle time of 2.6. Next slide just shows the summary of those calculations. And so now let's do the last set of tasks here, set of problems, and we'll build on what we've just done. So total time 9.4, idle time 2.62 workstations. And remember our cycle time is 6 minutes. So the first question here was total time available, number of workstations times cycle time. We have 2 workstations. Cycle time was 6, so it would be 12 minutes. Always important to include the units of measurement in an answer. Total idle time would be what we just calculated, the end time cycle time, so that's 12 minus the summation of the times. Summation of the times are here, 9.4. So that would give us 2.6 minutes. And assembly line efficiency, summation of the times divided by the n times the cycle time, total time available. Summation of the times is 9.4 minutes. N times CT is 12 minutes. Minutes divided by minutes, we'll be left with 78.3% assembly line efficiency. And you can again see the answers summarized here. That's it. See you next time.